Welcome to Aptera Bytes. In this video, I wanted to talk about the expected horsepower and acceleration numbers for the Aptera. So I wanted to start by showing this formula, which is force equals mass times acceleration. And so if you divide both sides by mass, you get force over mass equals acceleration. And so you can infer from this formula that if you increase the mass or weight of a vehicle, then you would ultimately have a reduced acceleration number for that vehicle. So I wanted to look into this because the Aptera is going to have 4 different battery sizes, and we have only received one horsepower number, which is 67 horsepower per wheel motor, and we have only received one set of acceleration numbers, which is 3.5 seconds to go from 0 to 60 miles per hour for the all-wheel drive version, and then 5.5 seconds for the front-wheel drive version. So that formula that I just showed does not apply to vehicles, and it turns out that it is much more complex than that. To determine this, I looked into a few of the battery electric vehicles that are out on the market and compared the horsepower for different battery pack options that are available, compared the curb weights, and compared the acceleration numbers. So I started with the Lightning, and you can see that there's a small battery pack option and a larger battery pack option, and both are all-wheel drive. And so the horsepower that goes with each one is 426 horsepower for the smaller version and 563 horsepower for the larger version. You can see that the curb weights are different by about 500 pounds, as you would expect with more battery cells being in the car. And the 0 to 60 measurements are different as well, but not quite what you would expect. So the smaller vehicle ends up with a 0 to 60 of about 5 seconds, and this is a reported number. The larger vehicle, I had to find a YouTube video where a test was done with one of these vehicles, and they got a number of about 4.2 seconds, although this is just an N of 1. So you can't make a lot from this number and this comparison, so I looked into a few other vehicles. The Ioniq 5 has a smaller battery pack and a larger battery pack option, and both are rear wheel drive, and the smaller one has a horsepower listed as 168 horsepower, and the larger one gets up to 225 horsepower. And the curb weights are different, as you would expect, by almost 500 pounds. And you can see that again, the smaller vehicle has a slower acceleration to 60 miles per hour than the larger vehicle. Now this one says 8.2 to 8.4 seconds. I had to deduce this number from a 0 to 100 kilometers per hour test measurement that was done, and so this is an inferred number. For the EV6, there's a small battery pack and a slightly larger battery pack option. And you can see that both are rear-wheel drive, and the smaller battery pack gets you about 125 horsepower, and the extended range battery pack gets you about 168 horsepower. And again, the weights are different, although not by much. And you can see that, again, the smaller vehicle gets a slower acceleration, and the larger vehicle accelerates faster. For the Leaf, there's a very small battery pack and a slightly larger battery pack, and you can see that both are front-wheel drive, and you get about 147 horsepower for the base model and 214 horsepower for the extended range model, and the curb weights are different by about 400 pounds. And again, the larger battery pack with more horsepower gets you better acceleration. Lastly, I looked at the Taycan, and you can see the very specific kilowatt hour numbers for the two models. The base model gets you about 321 horsepower, and the extended range model gets you about 375 horsepower, and they are both rear wheel drive. And the weight is just barely different, at least what is listed online. And you can see that the acceleration numbers end up being very similar. And so the listed acceleration for both vehicles is 5.1 seconds. This does seem to be true for the smaller battery pack model. The larger one, I did see numbers as fast as 4.61 seconds. So I thought that was very interesting. I was expecting that a larger battery in the Aptera would result in a slower 0 to 60 time, and I was concerned that the 3.5 seconds and the 5.5 seconds would end up actually being slower than that. But now we have to wonder if maybe a larger battery pack, such as the 600-mile model or the 1,000-mile model, may end up accelerating faster. I did have a lot of difficulty determining whether the horsepower should be dependent on the weight of the vehicle, and a lot of sources seem to suggest that the horsepower is only a product of the engine itself and does not depend on the weight of the vehicle. And then I saw this, which says that when you test horsepower, you hook the engine up to a dynamometer, and this places a load on the engine and measures the amount of power that the engine can produce against the load, which to me suggests that horsepower does depend on the load it has to carry or the weight of the vehicle. At this point, I wanted to emphasize that I am neither an engineer nor a mechanic or specialist in this field, and am open to any corrections that people can come up with for the content related to some of these intricate details about horsepower and acceleration. So here I thought it was interesting that 1 horsepower is equivalent to about 746 watts, which I thought was interesting because we are now talking about kilowatt hour battery packs, and it seems that horsepower is also dependent on the amount of energy that a battery pack can produce. And lastly, I wanted to show this chart, which shows the power to weight ratios, or the horsepower to weight ratios for multiple vehicles. And the conclusion of this chart is that if you have more horsepower and less weight, resulting in a higher ratio, you will likely get a faster acceleration from 0 to 60 seconds. So from this, the ZY formula came about. Basically, this suggests that the horsepower and kilowatt hour numbers are directly proportional to each other for vehicles. And so you can take the base horsepower, if you know the horsepower of a vehicle, and multiply that by the kilowatt hour numbers for the larger battery pack divided by the kilowatt hour numbers for the smaller battery pack. And this will give you the new horsepower numbers with a good estimation. And to show how this formula works, I applied it to the same vehicles. And so you can see that the Lightning, here are the reported horsepower values that I had shown before. And if you take this number and plug it into the formula with these two numbers, you get an expected horsepower of about 569, which is very close to the reported horsepower of 563. Same goes for the Ioniq 5. The calculated horsepower using the formula was actually the exact same as the reported horsepower. The EV6, you can see that it was again very close, 167 compared to 168. The Leaf, this one ended up being quite different. So the expected horsepower for the larger battery pack based on these numbers here would have been 228, but the actual reported horsepower is about 214. And then for the Taycan, you can see that again it was very close to the actual reported horsepower. So what does this mean for Aptera? So this really depends on what you consider to be the base model of the Aptera. I think the data that we are getting makes it very difficult to determine if they are giving the data for the 40 kilowatt hour battery pack or the 60 kilowatt hour battery pack. And I think you could even wonder if some of the numbers are for the 25 kilowatt hour battery pack. So in 2019, they reported that the 60 kilowatt hour Aptera would weigh about 1,800 pounds. And if you look at the specification sheet for Aptera, you can see that the weight of the vehicle is reported to be anywhere from 1,800 pounds to 2,200 pounds. And so you have to presume that the 1,800-pound vehicle would be the smallest battery pack and the 2,200-pound vehicle would be the largest battery pack. So if that were the case, then the 1,800-pound vehicle would actually be the 25 kilowatt hour battery pack. And here you can see again that the acceleration should be 3.5 seconds to go from 0 to 60 for the all-wheel drive version and 5.5 seconds for the front-wheel drive version. But the point of this video is to show that more than likely these numbers will vary based on the overall weight of the vehicle, which will depend on the battery pack that is in the vehicle. So right now the conclusions are that we cannot predict the horsepower for each option for Aptera until we know the base model size and the horsepower associated with that. But we should be able to expect that the smallest battery pack model will end up having the slowest acceleration and the largest battery pack model will end up having the fastest acceleration. So I will link an Excel sheet below, which I will update once we have more specific numbers. But you can also plug in your own numbers if there are new battery electric vehicles that come out and you want to compare the expected horsepower for an extended range version before we have the actual numbers. And ultimately, you will be able to use these numbers to estimate the acceleration numbers.